Let's discuss concentration, that is molality, in this particular part of the chapter, that is solutions and colligative property. Now, to begin with the discussion of molality, let us first talk about symbol, which is nothing but small m, and it is a W by W type of concentration. And let's have a look at the definition, which is very simple, and it says that molality is defined as the number of moles of solute which is present in 1 kg of solvent. And hence, if I look at the formula is molality small m is equals to number of moles of solute divided by it is a mass of solvent in kg. And since numerator is mole and the denominator is kg, the units are mole per kg or mole kg inverse. Or the other possibility units are either you can write small m or you can represent as MOLAL, that is nothing but molal. If you see the formula for molality, it doesn't depend upon volume, so it is volume independent. So obviously it will not depend upon temperature also, so it is a temperature independent concentration. So that's what we have for molality. Let's have a look at its application in the form of numerical. The first one, 11.11 gram of urea was dissolved in 100 gram of water. Calculate the molality of the solution. Given that N is 14, H is 1, C is 12, O is 16, these are all the atomic weights of the element nitrogen, hydrogen, carbon, oxygen respectively. Let us first go with given, that is solvent, and solvent is water over here having 18 gram mole inverse. The solute over here is urea, whose formula is NH2CONH2 and molar mass is 60 gram mole inverse. Let us go with the data. It is 11.11 grams of urea, that is nothing but W2, which is 11.11 grams, and 100 grams of water, which is nothing but the weight of solvent W1. And they are asking to calculate the molality of the solution, that is small m is equals to question mark, and the formula which you're going to use is nothing but the formula for molality, which is nothing but number of moles of solute upon it is a mass of solvent in kg. Now, since we require the mass of solvent in kg, we have that W1 over here as 0.1 kg. Perfect. Let's go ahead with the entire thing. Formula is molality is equals to number of moles of solute upon it is a mass of solvent in kg. We need to find molality. First thing, do I have the numerator number of moles of solute? No. Do I have the denominator mass of solvent in kg? Yes, I have it as 0.1. So first we need to find nothing but that is number of moles of solute N2, which is nothing but W2 upon MW2. W2 is 11.11 and MW2 is 60. And if I divide this, the answer is 0.1852. So now if I substitute the values, the numerator is 0.1852, denominator is 0.1, and if I divide this, the answer is 1.852 mole kg inverse, and that's the calculation for such a type of numerical. Let's have a look at the second numerical. What weight of solvent is required to prepare a 1.9 molar solution of NaCl if the weight of NaCl is 10 grams? Given the solvent is water by default if it is not specified. The solute is NaCl, whose molar mass is 58.5 gram mole inverse. Let's extract the data. Molality of solution is given as 1.9. Weight of NaCl, that is nothing but solute, is given as 10 grams. And what exactly are they asking is the weight of solvent, that is nothing but W1 is equals to question mark. And what formula are we supposed to use? Since molality is given, by default we have to use the formula for molality, which is number of moles of solute upon mass of solvent in kg. Since we have this data and this formula, let's go ahead. Molality small m is given, number of moles of solute is not known, and mass of solvent in kg, that is W1 is equals to question mark. So let's go ahead with the solution. First we'll try to extract number of moles of solute, that is numerator in the formula for molality, that is N2, which is W2 upon MW2. Do I have the value of W2? Yes, definitely it is 10. And what is MW2 is 58.5. So division will give me a value like 0.1709. So I have the value of number of moles. Let's go with the formula for molality, which is nothing but N2 upon W1. So from here I can get the value of W1 as nothing but what? N2 upon small m. N2 is nothing but 0.1709 and molality is 1.9. So if I just solve this, the answer is 0.0899 grams. So the answer of W1 is 89.9 kg if I just convert from grams to kg. Let's have an important look at this particular note over here. 1. Concentration of 1 molar aqueous solution is greater than concentration of 1 molar aqueous solution. Please note. Secondly, for a non-aqueous solution, your molarity can be greater than molality or vice versa, or it can be equal, but that purely depends upon the density of the solution. So please make a note of this. There can be an entrance question on this particular part, but the question can be direct. So don't worry about the derivation part. It's just you have to remember this. Thank you so much.